Howdy everyone, this is Ari Danish with Side Effects, and today we're going to do part 2 of the particle stream wedging with PDG tutorial. Specifically, we're going to do a top-centric approach this time. Last time, if you remember, we took a Houdini network and we brought in parts of it into the top network. Specifically, we overrode parameters in that Houdini network. This time what we're going to try to do is drop down a top object and dive inside and build a whole particle simulation within TOPS. So just as a reminder from last time, our objective is to create a simple particle stream and repeat the particle birthing several times with different seed values. In our case, we'll do it 3 times, giving us 3 wedges of particles, and then we could use image magic to overlay each of them into a fuller, thicker particle stream. But hey, we already did that. And really our goal is to make a top-centric version of it, so everything in tops. So let's make it more complex today. So here's what I'm thinking. We're going to do that 3 wedges that we did last time, the seed and color. Then we're going to drop down another wedge, cascade it, and we're going to make another, what I call a wedge structure of orbit scale and section scale, so we can control the particle curve force. So that will give us a total of 3 wedges times 4 wedges, 12 wedges to work with. And then we're going to wrap the geometry out for 10 frames. Remember, we're going to start off really small, a small data set to test on, make sure it works, and then you can expand it as large as you want. So that will give us 120 BGOs rendered out. We'll take those 120 BGOs rendered out and do a mantra for it and render it into image files. So we'll do 120 PNG files this time. Last time we did the EXR, I thought, hey, let's try PNG. Now the other thing to notice is that this ROP geometry is going to really be the heavy hitter of this whole PNG network. Why? Or I should say PDG network. Why? Because we're going to dive inside and we're going to build the whole particle simulation inside it. Okay, so we got all these image files of that 3 wedges of seeds times the 4 wedges of orbit scale and section scale. So we now got to bring it back. We got to partition it by attributes so we could get it back to what we needed to work with. So we're going to use a partition by attribute, and we're going to do it on 2 attributes, frame number and orbit scale. So that will get us back down to 40 work items. We put them in different buckets, and we'll be able to see what we saw originally, the different 3 wedges here of each frame of our simulation. Then what we're going to do is we're going to do a composite overlay to get that thick version that we like. And then we're going to partition by frame. So we're going to get those 4 buckets of the different orbits, scale, and section scale. And that will give us the different looks here. Finally, we'll do a mosaic for image magic. Last time we did an overlay. This time we'll do a mosaic so we can actually compare which wedge do we like the most to go in, for our projection run, for our big run. And that's what we got here. So let's go into Houdini and do it. So I'm going to drop down a top network and dive inside it. We got the local scheduler. And the first thing I'm going to do is going to copy and paste from the last time that wedge birth seed that we did, because it's going to be identical. Now just remember, for now, we don't have any target parameters to override. This is from the old one, so we're going to have to update these once we've dropped down our new ROP geometry that we're going to point into. Okay, but again, it's got the seed, it's got the colors, and we're good. So now I'm going to just drop down another wedge. And this time we said we wanted 2 things. We wanted orbit scale and we wanted also a section scale. And again, right now, we don't know where we're going to point to, so we're just going to have to, mentally remember that we got to go and fix these items here. Let's just do a little color coding to just remind ourselves that, hey, we're going to have to fix that once we have it. And they're both floats, so let's make the range of the first one 5 to 45 on the orbit scale. And on the second one, for the section scale, let's say a 3 to 10. And you know what? We'll make the second one kind of random too, just for fun of it. So one is going to be consistent of the wedges. Oh, and we got to say that we want 4 wedges. Okay. So just to make it nice and easy to remember, this one is the wedge for orbit and section. So now comes the fun part. We're going to drop down the ROP geometry. And the ROP geometry has got to be by frame range. We're going to render out for 10 frames, which is down here. And remember, it's F star to Fn, so that's good. Then we got to give it an output file name. And what I chose, not there, but in here for you guys to see, is hip geo, and then particle wedge with a wedge index and backticks. So again, this is going to be a constant. This is all our wedges. Then I want the wedge index, so I have a unique identifier for it. And then the frame number. Now remember, why am I doing both the wedge index and frame number? Because if I just did frame number, right, I'm going to be doing the same frame 4 times, so it's going to override each other. By giving it a wedge index, I have a unique, here's the wedge number, it's unique, and of that wedge number, what frame am I into it? And then I'm going to give it a BGO, and then BLOS compression at the end, .sc, which is not mandatory, but it's nice. So I'll just copy that, and go back here and just put it down. Paste it. Cool. So now I'm going to dive inside, and I'm just going to paste something I just copied, which is the geometry for the circle for the emitter right there, and the curve, which we're going to use for the particle curve force. And remember, there's not enough points here, so I just did resample and got enough points to be as attractors for the particle curve force. Great. So what's next to do is just drop down a PopNet. Now, one of the things we're going to have problems with is the circle doesn't have any of the attributes. Neither does the curve force for our wedges here. Okay. So how am I going to pass along the information like frame or orbit scale or section scale or anything else I need in any of these tops? And actually, I should do this while we're at it. Just cook, select a node. You can see we got the 3 wedges, and here we got the 12 wedges. If I select on this task info, you can see that I do have indeed the peak color attributes, the C channels, somewhere the orbit scale, and the section scale. Okay, so we need to pass that information along, and the way we're going to do that is real simple. You'll notice here that we have an incoming file operator built into our ROP geometry, and it's only pointing to app PDG input, which means it's grabbing everything from the previous chain upstream. So we could just drop that in here into our PopNet as context 1 to let that information pass through. And I'll just cut the output for now. We'll use that later. And then I could take my particle emission geometry and put that into context 2, and then my particle curve force as context number 3. And it's going to error out for now. Don't worry about that. We'll take care of that real quickly. I'm going to dive inside, and first thing we know is we got to put that pop color down. And that pop curve force like we had last time. And we're going to want to override, remember, the color here. And we're going to want to, on the curve force, to go to our individual forces, and we said we're going to take care of override the orbit scale and the section scale. So, those are the things that we're going to play with, and I'll make that into nice pink, because we know that's what's going to be driven. And so in the source, the seed values. Okay, but right now it's erroring out because in my particle source, the emission type is scatter onto surfaces, fine, but the geometry source says use first context geometry, and we're actually using the second context. And now you can see the error's gone away, and I got my little particle stream there. I go to pop color, everything's fine here, and the pop curve force, everything is ready to roll. Okay, incoming is still an issue. We'll take care of that once it's run. Now comes the output issues, and that's a little trickier. I crashed my back, so what we're going to need to do is drop down a DOP import. Nope, I mean a DOP IO. That looks much better. The DOP IO, we're going to wire to the output. And we're going to say, okay, what's the network? Well, the network is just this popnet here, so that's pretty easy. /popnet. Okay, and then for the DOP node, that's the pop object. So we're going to have to go in here and find it. Pop object. And let's see, we're in topnet 2 here. There's the popnet, there's the pop object. And we'll just say accept. And we got it. So that's ready to run. Okay, so we have a whole system here ready to go. But now I got to go back to the wedge birth seed and the wedge objects section and just rearrange this to make sure that we got what we want. So this is ROP geometry of topnet 2 to start with. So let's update this to topnet 2 for each of these guys. And then it says the target parameter is for this ROP geometry particle stream. I like that name, so let's just call that the same thing here. And now we have to get our pointers to the wedge orbit section for the orbit scale and the section scale. So I'm going to turn on my target parameters. And I'll go here. And I believe it's, we'll just go here and type orbit and see what we can find quickly as our wildcard. And we're in topnet 2, ROP geometry, SS, popnet, pop curve force, the actual curve force, the individual forces. Yep, that's in that tab. So we want the orbit scale for this one. Which is called scale orbit. So I'm just going to copy and paste for this one. And this one is going to be the scale suction, so I don't have to go through that whole thing again. And there it is. So let's do a dirty all. Just make sure. And then I'm going to go and cook selected node. And I'll be back when it's finished rendering. I canceled the rendering because I realized I forgot one thing, and then when I did a test of one of these work items, I got files with just 1K, in other words, nothing inside. And what I did wrong was this. The .io, I forgot to turn off import simulation settings, and then here, for the fields to import, let's do 1. And we're going to say import the visualization, no change, but the field that we need to look at is geometry. We want to convert it to geometry objects. So now when I render it, so I'm going to go here, DOPS, delete all results from disk, okay, and dirty all, just make sure, save. I'm going to render it and come back when it's done, and we should have real geometry being saved to disk. Well, it turns out that I had one more little bug, an oversight. I forgot in the wedge orbit section to turn on override target parameters to make sure that these guys actually do drive the parameters inside. Once I did that and rendered, all was fine. View task output. And as you can see, looking good. Oh, I should mention that while I was at it, I realized it was too large of a force, so I changed this to 3 and 7. You can fiddle with this. Again, this is not the key to the exercise. The exercise is PDG, not the sim, but play with these values to get something that you like. Okay, let's look at the chart and see where we're at and what we have to do next. Well, we already created the 120 BGOs, so it's now time to create the 120 PNG files, which is just done with the ROP mantra, which is quite simple to do. So let's hop back into Houdini and just drop down the ROP mantra. And let's just bring this up a bit so we can see. Now the key things here for the ROP mantra is one, remember that we want to render as a single frame, not a frame range, because we got all the geo files. And we need a output name here. So what did I pick? I picked right here, hip render folder at PDG name to make it unique, and backticks again, and .png to make it a PNG file. Okay, and before we render, we got to render something. So remember, we got to go back up to the object level and drop down here a file node. And the file node, all we're going to have is a app PDG input. So you guys can see, again, impact tick so it evaluates to say we want to render this file object with the file geometry inside it, whatever is upstream from the mantra node that we're rendering. Cool. So let's go here. Hopefully I just didn't close my Houdini session. And there we go. And I'll just copy and paste that, which I did. Oops. Undo. We did the file. I got to turn on the display flag for it. There it is. And now we should be able to just render it out. And say cook selected node. And I'll be back when it finishes cooking. And do we have good results? Let's take a look. There's one. Let's try this guy. Two. One last one. And three. So, yeah, looks like we're getting good results. So what do we have next to do? Well, if we go back to our chart here, we got our PNG files now. So the next thing is to get the partition by attribute. We're going to do it on frame and orbit scale. Something that you should notice is, okay, these are structures. So I got the seeds, I got the wedge output. On the wedge output, I have scale and orbit scale and section scale. I only need to call out one of these for the buckets to work correctly. Okay, so I'm going to drop down the partition by attribute. There we go. And remember I wanted to do it by two attributes. So I'm going to go click to get them to two. The first one being frame, lowercase f. And remember, I could always go here and say task info and see that it is indeed a frame, which is a float. And the other one I want is orbit scale, which is also a float. So I'll type both of those in. And change both of these to float. And I'll save. And if I try to cook this right now, I get the wrong results. I get these two outputs. Let's just look at that task info. And it's basically just giving me a bucket, as you can see, of all the frame numbers and then the orbit scales. So I need to change this a bit. So the first thing I want to do is here change the partition by attribute name to distinct attribute values. Okay. And let's just do that by itself because that's still not going to work, but it's an interesting exercise. Now I got 14 items. Because whoa, I didn't mean to do that. That's pretty cool. That should probably crash the system. Remind yourself never do that again. But again, let's go here, this time task info, and you can see that there's 14 buckets, and it's not what we want. What we really want is to be able to say, find the distinct attribute values of, let's say, frame 5 and orbit scale 7.2. All the ones that are equal to frame 5 and orbit scale 7.2, put that in a partition. So we're going to turn off partition attributes independently so that these guys are coupled together, and kind of just like a database, you're prioritizing your sort based on these two fields. So if I now go here and say dirty and cook selected node, I'm down to 40, which now makes much more sense because now with the 40 items, or the 40 partitions, what you're going to see in each one is not task output, but task info is just basically the wedgings, the 3 wedgings that we want for each of these guys for the burst seed. I realized after I recorded this video that I really didn't explain the distinct attribute value and why I turned off the partition attributes independently. So let's spend a couple of minutes and go over that one more time. So let's change this back to the original default attribute name and turn on partition attributes independently. If I cook the selected node here and say OK, I only get 2 work items. Why do I only get 2 work items? Well, I said partition by the actual attribute name. And I only have 2 attributes here, frame and orbit scale. So that's exactly what it's partitioning to those 2 work items, one for frame and one for orbit scale. I have another option here, specific attribute values, which is going to actually test for a value of your frame. So let's say I wanted to bucket all frame 5s and all orbit scales of 7.2. That's what that would do. But that's not what we want either. What we want to do is be able to bucket all the frames, let's say all the frame 4s that have an orbit scale of 6. Okay? So that's why I'm going to change to distinct attribute values. If I change it to here, but leave partition attributes independently and do a cook selected node, you'll see I get 14. But I have 10 frames. That doesn't make sense. So what's going on here? Well, in the ROP geometry, we said we want to render frame 1 through 10. That's where our frames come from, so that's 10. And then in our wedge orbit section, we said wedge count of 4. So 4 times 10, 4 plus 10, I should say, is because we're doing it independently. 4 plus 10 will give me 14. When I turn this off, I'm saying don't look at these guys independently, but look at them as kind of like in a database where you're doing kind of a sort by a couple of fields. You're saying find me all the frames that are equal to 4 and all the orbit scales that are equal to 7. When I run it now, you can see I get the 40. Again, that would be the 10 frames times the 4 wedges that we created for the orbit section or orbit scale to give me 40. If I look at the task info for this, task graph table, I guess I should call it, you'll see exactly how it lines up. Here's all the frame 1s for each of the orbit scales. And inside that will be the 3 partitions for each of the RGB wedges that we have created up here with our 3. So each of these structures that we have here now, embedded in it will have the 3 RGB values. And so there's all the frame 1s for each of the orbit scales, all the frame 2s, so forth and so forth, all the way up to frame 10. And I'll prove that point by our next step. So we said partition by frame and orbit scale. And then the next thing we have to do is just the image magic and do a composite overlay. So we're going to take each of those 3 frames or the 3 wedges up there and just do an overlay, which is identical to what we did in the last tutorial. Not montage, we're going to change that to composite. and say overlay, or you can try soft light too. Let's do soft light this time. And click selected node. Say OK. And this should be really quite quick. I'll look at task output for this. And there they are, and you can see that I got slightly different colors here, and they're composited. And it's working. Great. So we got those buckets taken care of, the composite overlay. Now we want to partition by frame because we want to make this mosaic here and see which wedge we like best of each frame. So partition by frame. We can use the defaults here. Cook selected node. And yes, 10 frames. Everything's coming out really nice now. And what's left on this, we got to wait for all of them to be finished, and then we'll do an FFmpeg. So wait for all. So this is going to basically collect all the partitions into one bucket for us to then be processed by FFmpeg encode video. And we could just leave it like that. That looks good. Cook, select a node, OK. And oh, I messed up here. I forgot on my system, I have it in a special place. I have it in /applications. On yours, you probably could use the default build and utilities /FFmpeg. And now hopefully it will work. Now remember, for this, you're not going to be able to see it directly, so it's just going to show you a link to it right here. Let's see, it's 9:15. Yes, so this guy. Ooh, something went wrong. So let's find out. Well, obviously I skipped a step, and the step I skipped is I forgot the second image magic. So I got the image magic here for the composite, but after the partition by frame, I forgot to put in another image magic. And this one is going to be the montage. That looks good. Then the wait for all. So I could just go here, dirty, and cook select a node, say OK, and hopefully this time the results will be much better. And there you go. And you can see 4 distinct suction orbit scales being wedged together to give you variances, and then you can decide which one you want to go for and create another network just that works on this one specifically. Well, I hope you enjoyed that tutorial. Look forward to making more for you guys.